There are other ways that we can put together confidence intervals, but in this class, confidence intervals are always a center plus or minus a margin of error. So the interval is always going to be center plus or minus margin of error. And I'll quite often take this margin of error, and I'll call it MOE, which is short for margin of error. Okay? It's still pretty vague though, isn't it? Does any of you have any idea what we're going to do with this now? What do we need to do? Two things we need to come up with, right? We need to figure out where the center comes from. We need to figure out how big that margin of error needs to be. Okay? So let's start with the center. Where should that center be?
In the middle.
In the middle of what?
The data values.
In the middle of the data values. What data values are we talking about? It's the right idea. Well, the center is the center of the interval. It's the middle of the interval. Okay, so there's no question about that. Remember that this p hat, we talked last week about what? Sampling distributions. Sampling distributions are what we can expect of these p hats, right? Sampling distributions, we know these p hats have different values to them. What is the shape of the distribution of those p hats when we do this? Think back to a week ago on Monday, we were flipping coins. When we flipped coins, we counted the number of heads. If we divide the number of heads by 10, the number of flips that we took, that's the proportion of heads out of the coin flips. We each had different proportions, or actually not everybody had different proportions, but we had different proportions and they had a distribution to them. What was the shape of that distribution? It was a bell shape. Where was it centered? It's centered at P, population parameter. So the distribution, the sampling distribution of sampling distribution of the estimates is approximately bell-shaped, and it's centered at the population parameter. Okay? Now remember, I don't know where that is, do I? Because I don't know that population parameter. That's what I'm looking for. Now, if I'm constructing an interval that I want to tell me something about that parameter, where should the center of that interval fall? We'd obviously like it to fall on P, wouldn't we? But we don't know P. So what's the next best thing that we can use? P hat, sure. This center will be this estimate. Okay? So we'll always have the estimate of the population parameter as the center of our confidence interval. Okay? So that's what we're going to put in the center. We're going to take that p hat and make that the sampling.
So in the margin of error then, is that just the uncertainty then of that value, or that it could be between this range?
It's kind of the way we think of it, yeah. What we're really going to do is we're going to design this so that if we want a certain level of confidence, we're going to set up the width of this interval such that, for example, if we want 95% confidence, we'll say that we're going to be 95% confident that that interval actually straddles the true population parameter.
So would less confidence mean a smaller interval? Or does it not always work that way?
What do you guys think? The way I usually think of this is I think of it like a fishnet. This interval that I'm creating is like constructing a fishnet. I'm trying to catch a fish. The fish is that population parameter over there. The place I want to put my net, my best guess, is what my fish finder tells me, p hat. Okay? The next question is, how big do I make my net? If I want to be more confident of catching a fish, what should the net be? Should be bigger, right? So the more confident, the larger the net. So that relationship is true. So what we have is that if we want to increase confidence, that implies increasing the width of my net. My net is exactly one margin of error to either side of this center, so that means I want to increase my margin of error. So the increasing confidence means increasing margin of error. And the other way works as well. If I decrease the margin of error, I'm going to decrease my confidence. Just like if you were thinking about a fishnet, the larger your fishnet is, the more confident you are that you've got the fishnet large enough to capture the fish. Okay? We're still pretty vague though, aren't we? I've said it needs to be bigger to be more confident, but we haven't said how big yet, have we? How big should it be? If I want to be 95% confident, how big should that net be? How big should the interval be? What do we have that could tell us how big that net ought to be?
Empirical rule.
Empirical rule, sure. We know that this distribution has an empirical rule that says that around this, plus or minus one standard deviation is 68%, plus or minus 2 is 95%, plus or minus 3 is 99.7%. So that says that if I want to be 95% sure that my interval is going to straddle the true population parameter, then I probably ought to use what is my width.
Plus or minus 2 standard deviations.
Sure, plus or minus 2 standard deviations. Okay? So I'd really like to have this margin of error be plus or minus 2 standard deviations.
But won't that, I mean, it's not always going to come out in a perfect bell curve, will it? I mean, it'll still be, the bell curve will still be a little bit off. I mean, even with, you know, a really good sample. So isn't that kind of going to
Sometimes
throw the percentages off?
You're thinking kind of the right direction, but I have to try to stop you because sometimes when you think that direction, you're going too far. If you're looking at any particular sample, the true distribution of that particular sample will never be a perfect bell shape.
So you just go with kind of the best guess, or?
Bell shape is an idealized,
Okay.
and it gives us a best guess at what it should be. But we have another problem here. This population parameter is something that we don't know. The standard deviation here, this width, is also a population parameter. We don't know it. Okay? So what I'm going to do is we're going to come up with ways of estimating standard deviation. Just like we said, this estimate, p hat in this case, is our best guess at the center of the interval.